Hi everyone. In this video, we'll try to understand how you can deploy your own token on the Solana blockchain and how you can distribute those tokens amongst your friends. But before we do that, we need to understand how data is stored on the Solana blockchain. So let's understand how we store data in the Web2 world. In the Web2 world, we usually have something called as a database. And anytime a new person joins your platform, you make an entry in this database corresponding to that user. If this user wants to interact with your database, they usually send a request to one of your servers, and then that server fetches the data from the database and returns it to your user. So this is a very common model in Web2 to store and retrieve data. Now let's try to see how Solana does this. So on Solana, anytime you're interacting with a program, and this program is basically a smart contract that's deployed on the Solana blockchain, and if this program needs to persist state or persist data across transactions, it'll basically create a new account for you. And this account is basically very similar to an account that you hold your Solana tokens in, but it will also hold some data inside of it. These accounts are also known as program derived accounts. And if you look closer into it, these accounts have three special properties. They store some application specific data. They're owned by a program that has read and write access to them. And someone needs to pay rent in the form of Solana to keep these up on the blockchain. So if you want to store data on the blockchain, you basically need to pay some rent. You can be rent exempted if you send Solana equivalent to 2 years of rent. So basically, if you send Solana to an account which is equivalent to 2 years of rent that would have been debited from it, then no Solana is debited from that account and it becomes rent exempt. So getting back to how data is stored on the Solana blockchain, if there is a smart contract that multiple people are interacting with, each one of them will have an associated data account or multiple associated data accounts for that program where they'll be storing their individual data. Each of these accounts will be owned by the program, and the program will have access to update the data as and when these users interact with the program. So to sum it up, if you're interacting with a program that needs to persist state across transactions, there'll be an associated account to store your data on it, and any other user that's trying to interact with it will have their own associated data account with it. And these accounts are how you store data on the Solana blockchain. Why is this relevant for this video? Well, that's because when you're creating a new token, this token is actually a smart contract, and anyone who wants to own that token needs to have an associated data account where their transactions and the amount that they hold will be stored. So if you hold multiple such tokens, you'll basically have one data account associated with each and every token, which will store data relevant to that token. And we'll see this later on Sol Explorer as well after we complete this assignment. So let's get into the coding bit now. Specifically for this video, I've already coded this since this is a longer program. First thing that you need to do though in your project is install the @solana/spl token library. This library basically contains a bunch of helper functions for you to interact with the SPL token contract, which basically governs the creation of these tokens. If we go inside the main function, the first thing that we see is that we've created something new called as a mint wallet. This is basically a new wallet, and this is called the mint wallet because this wallet will have the authority to create new tokens or create a fresh supply of tokens for this new token that we're defining. The first thing we do on line 34 is to airdrop a bunch of Solana into this wallet, because in order for it to create a new token, it'll need to pay some transaction fees. Then on line 35, we're calling a new function called the create mint function, and we're passing in the mint wallet to it. It's a fairly small function. We're first creating a connection to the local net. Then we're defining a new variable called creator token, which is basically what is returned when we call token.createMint. Now this createMint function is what actually ends up creating a new token on the Solana blockchain, or not exactly a token, basically a mint from which you can create more and more tokens when you want. And if we look at this function, it basically accepts a few arguments. The first one is the connection. The second one is the pair who will pay for this specific transaction to create this token. And in this case, that's just the mint wallet. The third one is the mint authority. Basically the wallet that will have authority to mint the supply of this token or create new tokens of this type. The fourth one is freeze authority, which basically means a wallet which has the authority to freeze these tokens. And the next one is called decimal, which means the number of smaller decimals that you can break down a single token into. The value for Solana is 10^9, and each one of these is called Lamport for Solana. And you can define your own decimal supply over here. If the supply is 100, that means a single token can be broken down into 100 smaller parts. And the final argument is program ID. You can ignore this for now, and we'll just be passing in a constant to it right now. Later, we'll try to understand what is the need of this argument and whether or not it will always be a constant. Finally, after we've created this mint, we just return the public key of this newly created mint back to the main function, and that's stored into this created token address wallet. So now up until this point, you've created a new mint. You have the public address of that mint, and you also have the public and private key for the mint wallet. The mint wallet being the authority that can create more supply of these creator tokens. Next, let's try to transfer some of these tokens to a friend of yours. So we've written a new function called transfer tokens, which takes in 3 arguments: the creator token address, basically the token that you want to transfer; the mint wallet, which is basically the wallet that has authority to mint these creator tokens; and finally the wallet that you want to send these tokens to. So again, up until this point, this token has a supply of 0, which means the supply of this token is 0. Even though this token exists, no one really holds any of these tokens, not even this mint wallet. What we have to do now is we'll first have to create a supplier for these tokens, as in mint some of these tokens, and then transfer these minted tokens to this address that we've accepted as an argument. So let's try to see how we do that. So the first thing we do is create a connection. The second thing we do is we basically initialize a creator token function. So we're not really creating a new token here, we're just creating a local variable, and we're passing in the token address and the mint wallet to it as arguments, so that we get the same variable that we have on line 7 on line 13. So this is just a local variable, and creating this doesn't really interact with the blockchain. Now, if you remember from our initial discussion, in order to store data on the blockchain, every account that wants to interact with a smart contract and wants to store data corresponding to that smart contract needs to create a data account on the blockchain. So that's what we're doing on line 15. The first thing we're doing is we're creating a mint token account. What that means is this mint wallet that we have, we're creating a corresponding data account for it, where we can store the data corresponding to this creator token. And that can be done by calling creator token.get or create associated account info. So this will basically create an account if it does not exist. And if it does exist, it'll just return the value of it. Next thing what we need to do is we need to actually create a supply of these tokens. So we have already defined that this token should exist on the blockchain, but we haven't yet actually minted any of these tokens. That's what we're doing on line 16. We're calling the mint2 function, which will basically mint these newly created tokens to this mint token account that we created on line 15. So again, the account that we created on line 15 is a data account corresponding to the wallet address of the mint wallet. And on line 16, we've actually sent some newly created or freshly created tokens to it. But the purpose of this function is to actually create these tokens for our friend, the receiver wallet address. So now we need to transfer these tokens from the mint token account to the corresponding data account of the receiver wallet. So first we try to get or create the corresponding data account for the receiver wallet. And once we have that, we execute this transaction, which is very similar to the transaction that we saw in the last video, where we were transferring SOL from account 1 to account 2. Here we're not transferring SOL, we're transferring a certain token, where the owner of the token is this. This is the account that you want to send data from, and this is the receiver's data account where you want to send data to. And we submit this transaction on the blockchain. And once this finishes and confirms, the tokens are sent to the receiver's wallet. So let's see this in action and then maybe go over it again. I've also logged a few things here and at the end so that we can check these out on the Solana Explorer. So let's first try to run build. And once that's done, let's run So a few things are logged here: the receiver token account address, the creator token address, and the mint wallet address. So let's try to see each of these in the Solana Explorer. But before we do that, let's go to this address. I actually have it open on Phantom here. And if you see here, it has a bunch of these unknown tokens. So they don't have a name yet. But one of these tokens, if you look, has the public address of W96. This one right here. So this is one supply of that token that was recently minted by the Mint Authority and transferred to this wallet. Let's try to open these 3 on the Solana Explorer and see what it looks like. So let's begin with the token itself. So this was the creator token address. As you can see, it clearly states that this is a token. It has a current supply of 1, which is something we just created. It has 8 zeros after that, which was our decimal points here. And it has a few instructions that were just executed on it. If you remember, we called initialize account twice, once for the mint wallet and once for the receiver wallet. And it also has an instruction called mint2 that was called on it. And this function is what minted this initial supply into the mint wallet. Let's check out the other addresses as well. The mint wallet address is basically the same as the mint authority over here. And the mint authority basically represents a wallet that can create more tokens of this specific type. That's this one right here. It has a balance of 2 Solana, which is what we initially airdropped it. And finally, the receiver token account, which is basically the data account for the receiver. And as you can see, it clearly shows that this is the mint that this specific account holds, which is this token. And this is the owner of that mint. So this is this guy right here, or this account basically. Now you might be wondering what if the mint wallet keeps on minting more and more tokens and infinitely creates more and more supply. There is a way to restrict that. You can just set the mint authority to be null, and then no one else would be able to increase the supply, and hence the supply will be capped. I'll leave that as an exercise to this video, and from the next video onwards, we'll try to actually deploy some smart contracts that are written in Rust on the Solana blockchain, and then write client-side code that can interact with them. So I hope to see you there.